Check one, check two. I think we are going. We're live. We got some sound coming through. We are recording. Here we go. All right. Hello. Welcome to wherever and whenever you're watching in the world. My name is Alexander Booth. I am the head program instructor and head facilitator for the IBM Data Science Bootcamp. This is the week 6 review, week 7 preview for the Data Science Bootcamp cohort April 2026. So crazy, already in week 7, which is kind of wild. So we only have 4 weeks left, just about one more month of this, and then you'll all be graduating with your boot camp certificate. So should be a good time here. Week 7 is also where it gets pretty exciting with predictive models and machine learning, but I don't want to leak too much information. So let's get right into it. We'll start with week 6, which we just wrapped up a couple of days ago. So thanks to everybody that joined the live session on Monday. Week 6 was all about data visualization, dashboards, data applications, and business intelligence. Essentially, how do we craft stories from our data that really drive business decision making, right? Especially at the consumption layer. And that's typically what we talked about, right? We talked about as business consumers, less technical folks. We're just trying to understand the story that our data is telling us and use that to drive better decisions. How do we do that, right? So we talked about 3 big use cases for data visualization. The first being exploratory data analysis, where you, as the data scientist, need to understand your data even better. How do you become a domain expert in the stories you're trying to tell in the space that you're investigating? Second was for static visualizations. How do we create static reports, static images that we can put into a slide deck, that we can put into a white paper or print out into some kind of static report and share around the office? And then finally, the third most, and to me, the most important part of data visualization is on the interactive self-serve analytics layer. So this is where we really drive business intelligence by creating interactive, typically web-based or BI tool-based visualizations and data applications. So examples of this include your Tableau, Power BI, Looker, Click, QuickSight. I can name them all day. Actually, maybe not. I think that's all I got. But those are your business intelligence tools that you are dragging and dropping, creating interactive visualizations with dynamic filters that when you change, they change the whole dashboard. Now, we also talked about data applications, though. This includes your Streamlit, Gradio, and Dash apps through Plotly. And we focus a lot on the Plotly side of this, right? It's an open source tool, allows us to create interactive data applications as well as business intelligence dashboards. So that's another, we'll just kind of start with where we started from and then how we got there. So like we talked about, week 5 was all about exploratory analysis, and week 6 was expanding that into the larger consumption layer, static reports, dashboards, BI tools, and interactive data applications. So we started with those static visualizations. This includes creating your Matplotlib, your Seaborn charts, whether that's through Pandas or just the raw Matplotlib or Seaborn libraries. And then we moved into other advanced interactive tools such as Folium for interactive mapping and geographic visualizations. Plotly just for general interactive vizzes, and Dash for those interactive data applications. Let's see. We talked a lot about when to use the right chart for the right story. So hopefully this is pretty rote by now. Line charts for change over time, patterns over some seasonality, area plots, another kind of version of that, but showing more depth and more ink. Histograms, looking at the distribution of our data. That also is your kernel density estimation plots. Bar charts for looking at categories, pie charts for looking at percent of whole, and scatter plots as well as multi-line charts for looking at numeric correlations. Understanding what and how you want to visualize the data is super important. Then we talked about best practices for data visualization. Some of my favorites are the misleading charts and how misleading charts can distort stories. So this is either lying with your visuals, which I got some good examples on somewhere in the lounge. I'll have to go find it. I thought Yeah, I think Karen posted in one of the other chats, but we got some good visualizations of like misleading charts, and then Edward Tufte's visualization principles, including kind of the data to ink ratio, the dimensionality principle, and all that good stuff. Essentially, make sure that what you're visualizing is purely about the data, you are communicating truth, and you're not trying to distort that in any way. Let's see here. I'll also add in spurious correlations to this. I don't know if you've kind of checked out spurious correlations, but this is where like we identify patterns or signal in things that don't really exist. And I think that is something that also uh like can lead to just poor storytelling, right? So yeah, the distance between Jupiter and Mercury correlates really well with Anheuser-Busch's stock price. So how funny is that? Let's see what else we got. UFO sightings in South Carolina correlate strongly with the total number of Mount Everest climbs. Definitely nothing there. What's that one? I always like the bed sheet one. Let's see if I can find that one. Spurious correlation bed sheets. I can find it. Aha, there it is. The per capita cheese consumption with the number of people who died by becoming tangled in their bed sheets. A perfect correlation. So there you go. If you eat less cheese, you're less likely to die by being tangled in your bed sheet. But we know that's obviously not the case. The other one was what? What WTF visuals? Something like that. There we go. These are some more like bad visualizations. So I think Karen shared the Mike Glennon one in the chat. Like this is just hilarious. Just really poor and kind of distortion. And doesn't even really tell that good of a story. I would say that maybe the bars are supposed to represent the dollars, but like Cardinals at 5 million, that is not five times bigger than the Jaguars, right? So doesn't really make that much sense here. Um, yeah. Yeah, what is this nonsense? This is wow, time dilation. Yeah, it's wild. Anyway, if you want to see some bad charts, these are some good links for them. But yeah, we talked about like why these are bad charts, right? And I think that is the most important part here. Understanding how, yeah, look at that. Like that is not 38% of the pie charts, right? Pie charts are really easy to lie with. Also, that does not add up to 100 either. What 30 plus 22 is what? 70? No, 60. Plus, yeah, that's like 79%. So we're missing a whole 22% here. Anyway, we talked a lot. I have a lot of fun with bad visualizations. So then we moved into more advanced visualization topics. That includes waffle charts, word clouds, more advanced regression plots and visualization options, including statistical vises. We looked at adding error bars to our bar charts, as well as pair plots, things like that. Again, highly recommend checking out Seaborn for a lot of their really cool and fascinating statistical visualizations, your violin plots, your facet grids. Let's see what else you got. Oh yeah, the pair plots, we already talked about that as well. So pretty cool. Oh, swarm plots are kind of fun as well. They're like little bubble charts as well. Cool. Let's see. Where else are we going after that? Oh, then we got into the interactive visualizations. We did a deep dive on Plotly. So again, Plotly is this open source interactive plotting library. I think it's a bit dramatic. Every chart you've ever loved starts with Plotly. What about D3? I love some charts that start with D3 as well, but whatever. So we talked a lot about Plotly, how it can be used for both like JavaScript, R, and Python. And then we looked at their open source Dash option for building interactive dashboards and applications. Let's see if I can find an example of a Dash app. This is like Dash Enterprise, but the open source one is pretty similar. So, yeah, like how do you build out like interactive like web applications that surface and visualize your data as well as add in those filters and context and things too. So that's kind of the idea of developing, building, deploying, and operating data applications and Dash apps as quickly as possible. Let's see here. Then we did a couple oh, Looker. I forgot to mention Looker at the top. Then we did a couple of full end-to-end notebooks. I showed some of my favorite ones, including creating waffle charts and word clouds of Alice in Wonderland. And then we created our full interactive dashboard of the Australian wildfires in about a decade ago, whatever the dates were on that. Big ideas from week 6. Data visualization is not just about making charts, it's about communication, communicating those patterns, trends, and outliers, and relationships, making sure that less technical stakeholders or even non-technical stakeholders understand the data. Bad visualization can exaggerate differences, hide context, and lead to poor decision making and false conclusions. With great power comes great responsibility. It is your responsibility to be truthful and to tell good stories with your data. A couple good links here. Definitely talked about how plotting interfaces with pandas, Tufte's visualization principles, basically best practices around creating both static and interactive visualization, dashboard design concepts, all of that good stuff. You want to show labeling, proportions, relationships, standardized units, matching dimensions, contextual integrity, data to ink, all that good stuff. Let's see, we got some more. I think I shared this tutorial on building effective dashboards. Again, this will help you whether you're creating a Tableau, Dash, Looker, doesn't really matter. A lot of the ideas on dashboard design translate across technologies. Again, how do you make it clear? How do you make it easy for less technical people to understand? And how do you add context with numbers and text to really give that clear call to action, right? So, good stuff, good stuff. And let's see, all my stuff is backed up in GitHub already. I think it's probably worth popping over to GitHub. Let me see if there's anything else in the forums that are worth calling out here for week 6. Let's see, I wanted to highlight some of Karen's posts. Yeah, 6.8. So this is where we talked about like bad data visualizations as well, right? Like the misleading gun death chart. Yeah, this is crazy. Like, this whole thing is reversed, right? Um, it makes it look like a number of murders committed using firearms. It's backwards. It starts at 0, but it doesn't look like that, right? So you have 800, and then 700 is lower, but it's at a higher point than 800. Makes no sense. So this is like a whole backwards graph. And yeah, this went viral for being like a really bad data visualization. Up is down, right? Yeah, most people see a huge fall off in gun deaths, but it's actually not what it shows. That when they enacted the stand your ground law, we went from 500 gun deaths to 700. So it increased, but the graph is distorting that conclusion. But yeah, anyway, we had a good talk about like what is the main message you're trying to tell, and how do you like make sure that you're not impacting real decision making with your graph, right? So Karen had a good one about distorting the y-axis can really tell the difference in the story with bar charts, as well as like charts with just misread labels and things like that, right? No scaling on anything is typically a bad sign. So, good stuff in week 6. I always enjoy data visualization and data dashboarding weeks. Let me go find who are we? IBM. Let's go find some of my code for week 6. Here we are. So not only do I have all the notebooks backed up from the week, I also have my big ideas, my notes, and my lecture notes. So let me just make sure I hit everything here. Static types, make sure you understand a bunch of different plots and what they're good for. Advanced plots, geographic, geospatial. We'll dive deeper into Folium in week 10 when we get into the capstone, like week 9 and week 10. So don't feel like you have to memorize everything about Folium now. Let's see. I think that's mostly it. Key takeaways, yeah, always understand the visualization purpose. How do you avoid misleading the audience? How do we know the difference between static visualization, statistical, interactive, and dashboards? Let's see here. Yeah, I think that's mostly it. We did a deep dive into Dash as well with like event-driven architectures, but I think that's a little bit out of scope for this review. Um, yeah, I think it's just the idea. Build clear and honest visuals, deliver interactive dashboards as needed for self-serve analytics. How do you tell stories with data from static plots to maps to dashboards? And then for some of our live session code, we live coded out. Oh yeah, let me see if I can show you the word cloud. This is pretty fun. An error occurred. Come on, GitHub. What are we doing? Womp womp. Apparently, I can't show you the plot. But if you do load that, you should be able to see that we have like an Alice in Wonderland shaped word cloud, which is very cool. Let's see, on the Dash app, I think the only thing that's worth calling out is this idea of like callbacks and like this is how interaction works. We call this like event-driven coding, event-driven architecture. We listen for events and then react to those events accordingly. Sweet. I think that's all I got for week 6. So let's jump into week 7. Boom, 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 boom. Is that a Venga Boys reference? Boom, boom, boom. Great song, by the way. We like to party. Anyway, we got distracted. We don't need a Venga Boys breakdown right now. All right, let's get into the machine is learning week 7. I love week 7. Week 7 and 8 are both all focused on machine learning. In week 7, we're going to start with a deep dive into supervised machine learning, including regression and classification, specifically linear models for each. We'll go over how we are building models, building linear models, so your linear regression, logistic regression, evaluating those models, and doing kind of the end-to-end framework. And then in week 8, we'll add in tree-based models as well as unsupervised learning. And then that'll take us to the capstone. So big preview for week 7. Obviously, I've already run all the notebooks and backed everything up. I always do that in the middle of the week. So feel free to reference them if anything is broken or if you want to run things in Colab. Definitely use my source of truth. So for week 7, we're moving from analyzing data to actually building predictive models and writing those algorithms. Up until now, we focus on understanding data. Now we're going to start using that understanding, using those patterns and that signal that we've identified to really drive predictions, right? And reducing that uncertainty of future behavior of our data set. Like I mentioned a couple of minutes ago, we're going to be focusing on the two types of supervised machine learning, which is regression, predicting a continuous value such as price, emissions, or revenue, and then classification, which is predicting categories or predicting the probability of a specific category occurring. So the probability of someone churning versus not churning or surviving the Titanic or not, right? So we're going to work through advanced regression and polynomial concepts again. That's a quick review of how we ended week 5. Then we're going to spend most of the week on classification, since that is net new in the boot camp. We'll focus on logistic regression as well as model evaluation for logistic regression and classifications. So your confusion matrix, log loss, F1 score, classification report, all that good stuff. And we'll work end to end on building a scikit-learn model workflow, train test split, fitting your algorithms, making the predictions, and evaluating the model performance. Because again, if you know how to do all that, then it becomes just a matter of slotting in additional algorithms into your training experiment. Logistic regression, random forest classifier, XGBoost, CatBoost, whatever. This is going to be your first exposure to the full end-to-end machine learning lifecycle, going from data to feature engineering and preparation, modeling, evaluation, and iterating on that purpose. We're not just going to be running models, but understanding how, why, and when to choose different features or to engineer specific columns, how you evaluate performance for supervised machine learning models, how to avoid under and overfitting, as well as misleading results that a model can give. There's a lot to machine learning, obviously, and we only have 2 weeks and maybe like 3 hours total of me lecturing at you. So I highly recommend taking some additional practice over the next couple of weeks. I've already mentioned Kaggle Learn before, but I actually just rolled out some really awesome guides. I was looking at some of the AI and generative AI ones, which are really interesting. But anyway, I know no one likes TensorFlow all the way at the bottom. I remember when TensorFlow was the hot thing these days, but no longer. Anyway, if we look at some of the learning curl courses, you'll see they have an introduction to machine learning as well as intermediate machine learning. They also have one for feature engineering, which is really like unsupervised machine learning as well. So these three lectures or course micro courses, they supplement week 7 and 8 really well. So highly recommend taking the time to at least review them, just so some of these concepts around data exploration, model validation, overfitting, tree-based algorithms aren't so completely new and foreign to you. Honestly, I recommend all of the Kaggle Learn courses. You honestly can't go wrong with any of them. So, really great use cases, and that's partnered with Google and Google Cloud, and it's all free. So, it's only going to take a couple hours of your time to do them. Let's see. Big ideas for the week. Try to focus on understanding the big picture of predictive modeling and machine learning, not just running the notebooks or memorizing syntax, especially with a 10-week boot camp like this. Like memorizing syntax is not going to get you anywhere. Understand the 10,000-foot view, the purpose, and the big ideas here. Same thing, pay attention to the metrics, not just to how the model looks or something there. And we're going to talk a lot about using the holistic story of the metrics. So multiple metrics, multiple visualizations to help us evaluate model performance. Yeah, I like adding this note. Even though the linear model is called a logistic regression and it has regression in the name, it's actually a classification model. But we'll talk about that during the live session. And specifically for week 7 and 8, there's some weird stuff in the notebooks as the machine learning libraries have changed a lot over the last like 6 months. So my GitHub, like I literally run them the week and I do this live. Like these are not pre-recorded. So just definitely like check my GitHub and check my notebooks. If anything looks weird, it should have the latest and greatest in there for sure as a source of truth. Big shift in the course. Once this clicks, you're actually building machine learning models, not just analyzing data. I think we'll also tie this back to machine learning as part of the wider data science responsibilities in the data landscape, right? Like we don't just do machine learning for the fun of it. How do we tie those predictions back into dashboards and decision making? How do we tie it back to the input data, all with the way in the left of the pipeline, going back to garbage in, garbage out? So should be a fun week. Definitely try and watch the lecture if you have time. Karen's got some good stuff around some of the linear equations and the linear models. Mostly, I try not to get too caught up in the actual equations and all the Greek letters and everything in class. Big idea for linear models is that they're just rooted in mathematical truth, mathematical proofs, so they create a trustworthy output and a trustworthy and explainable algorithm. And then same thing for a logistic regression. You'll see kind of we got a deep dive in how we draw the decision boundaries of where to like how a classification model actually works. And again, like I think that's a little bit of under the hood. When we do create a classifier, we are essentially drawing a decision line, a boundary between our classes. And if I fall on one side, I'm green, otherwise I'm blue. And you'll notice that I like to talk about probabilities because the further away I am from the line, the more confident, the higher my probability is of belonging to that class versus the 50-50 dots that you can kind of see here in red. And it's like, yeah, you'll see this a lot in machine learning. Like if you actually achieve 100% accuracy, it's probably a red flag, right? Like you'll never see full truth and 100% in any model, right? Like it's impossible to fit a model like that to the past without it overfitting. So you want to be as good as you can get it, but don't be surprised if you never make 100% accuracy. Let's see. We'll cover some of the forum stuff next week. Try and participate in the forums this week if you can, if you're taking the course and have access to our dashboard here. Love to hear conversations around machine learning in the real world. And then we'll wrap this up by covering some of my GitHub. So like I mentioned, everything's already in GitHub except for my lecture notes, which I still haven't done yet, but we got a couple days to before the live session. Let's see here. Regression, classification, what's in here? What is the fundamentals of machine learning? How do we do our full life cycle? How do we create these like full models in the scikit-learn ecosystem? So I think there's not too many notebooks. I think it's just three notebooks this week. But we'll try and cover all of them in class as well. So kind of a review of week 5 with our advanced simple and multilinear regression. We're only going to try and like expand on the like best practices of the machine learning lifecycle in those. But we did do a lot of that on week 5. I'm going to spend most of my session on logistic regression, as that is net new, like I said. So how do we do that from top to bottom and understand that end to end? Let's see here. One thing you'll see me post in week 7 and 8, by popular demand, as I've been teaching this for a few years now, I have like my own study guides for supervised classification specifically, and then what does learning look like in production. We won't hit all of these in lectures over the next couple weeks, but it's definitely a good time to review or just to learn more, right? So these are already in my GitHub, but feel free to download them and kind of look at them when you can, right? So you'll see a deeper dive into like linear models, what it means to be like proven in mathematics, some of the like examples and tree-based models, all that good stuff. So that's like the supervised one. The classification one's good if you're net new to classification. What does it mean to have a classification problem? What are the different algorithms you could use to solve classification problems? And then how do you evaluate this? That's something that everyone gets confused. I'm still confused by it sometimes. But your true and false positives, negatives, and type 1, type 2 errors. So it should be a good time. Definitely use all the resources. We have a lot of content and a lot of support for machine learning. So please take the time to learn it. And again, the effort you put in is the effort you'll get out of this. So we'll lean in where we can as well. But yeah, we'll look in the forums for any questions, concerns, issues. And I hope to see everybody in our next live session on Monday. Enjoy the machine learning week, and the machine is learning. So have a good weekend, and I'm looking forward to seeing all the models and cool stuff that y'all create over the next few days in these labs. All right, we'll see everybody in the next live session, the week 7 live session on Monday. Take care, have a good night, and stay safe out there. Keep learning. I don't know. Cue theme song. Diddly diddly do. All right, bye everybody. Have a great night.